welcome to one of our first virtual Seed Perspective articles. I'm joined here by Dr. Dan Quinn from Purdue University. And you just spoke on smoke and the effects of it on our crops. So I'd love to dive into a little bit deeper with you because it's an issue that's hitting close to home in Western Canada.
Yeah.
So why don't you share a little bit with what you studied and how you studied it and your initial thoughts on how smoke would affect corn and soybeans?
Yeah, I think, it stems from, in the U.S. and the Midwest, we've had really the last 2 to 3 years really prevalence of smoke, where it's really come down from Canada, eastern Canada.
You're welcome. Yeah.
And so a lot of the farmers wanted to blame the Canadians for the smoke, but it came to the point where it became very noticeable for a lot of the farmers. Really in late June, they could see it, they could smell it, they could taste it, right? And that just automatically triggers the idea, okay, how is it impacting my crops, right? They want to understand. It's the number one call. One of the biggest calls I got was, is this detrimental to my crop? Is it beneficial? I don't know what's going on at this point in time. So the idea was that, because we got this question so much was, okay, let's try and maybe understand what's going on and maybe is it positively or negatively impacting the crops? And that's very challenging because of how difficult it is to actually quantify how much the wildfire smoke can impact the crop. But we just tried to do as much digging and summarizing of the information that's been done and try to share that with folks to give them kind of an indication of, actually did it positively or negatively impact that crop.
Sure. So you did the study specifically on corn.
Yep.
And the research paper is out, so we'll have a link for that you can click on and get the in-depth details. What was the gut feel on what it was doing to the crop, and was the outcome different than the gut feel?
So my gut feel was it actually positively impacted the crop. And the reason behind that is because of when it came in and also what the crop conditions were when that wildfire smoke came in. So a lot of the U.S. Midwest in June were very hot and very dry. And when that wildfire smoke actually came in, it drastically reduced the temperatures, upwards of 50% plus reduction in temperature for 3, 4, 5 day span. And those crops, it almost was a crop basically took a breath, right? We saw lower transpiration rates, we saw lower leaf surface temperatures. That crop just wasn't burning as much energy and losing as much moisture when that wildfire smoke came in. So I do, that can very much change if the wildfire smoke came in during, say, pollination or different periods during the growing season. But when that wildfire smoke came in and that condition that crop was in when it came in, it gives us pretty good indication that it benefited the crop because, at least in Indiana, where I'm from, we had state record yields, right? We had farmers that had the best yields they've ever had in their lifetime this past year.
The one thing I want to kind of draw off that is last year in Manitoba alone, we had a new record for average canola yields. And we didn't have as much smoke as we've had in the past, but we definitely had smoke present in the July timeline. A lot of feedback we heard from growers of what they saw is delayed maturity, cooler temperatures. However, what I'm trying to compare and relate to is a canola crop, which is a different animal in terms of harvesting sunlight. Have you looked into how a C4 crop like corn and another crop like canola, which is a C3, photosynthesizes light in a C3 form? Are we going to be able to draw similar parallels or not?
I think there is some similarities, right? And the way we looked at this was predominantly the light saturation point. And what I mean by the light saturation point is, the crop utilizes a certain amount of light. So if you take a graph and you're looking at photosynthesis versus light interception in that crop, and eventually there's a point where if we get any more light, that crop just isn't going to photosynthesize anymore, right? It's got as much as it needs. So corn, being a C4 crop, has a higher light saturation point. But soybeans, a C3 crop does have a light saturation point too, so it doesn't mean that it's not impacted by that reduction in light. We just have indication that a crop like corn, a C4 crop, is probably a little bit more sensitive to changes in light. So if we see, say, a reduction in light, it's more likely that that crop, in terms of negative impacts, is probably going to be a lot more so in a C4 crop than a C3 crop. Now, if you look at CO2, that kind of changes, right? CO2, now a C3 crop is going to be a little bit more sensitive to changes in CO2 versus a C4 crop. But both crops, right, they both have light saturation points, they both have sensitivities to light. It's just an indication that a crop like corn that's much taller, has a little more multi-layer canopy, is probably going to be impacted a little bit more by changes in light.
Sure. Yeah, that makes sense. It's one of those things that timing plays such a big role, and you mentioned it right at the beginning. For us, we saw timing have an impact where guys couldn't get in the field as soon. And when you've got that crop sitting in the field, there can be a negative connotation around that because you want to get it in the bin and you want to pay the banker. Is there a certain time that you know, maybe drawing this into soybeans, a timing of smoke cover versus not, that might have more or less of an impact on soybeans?
I think it really comes back to the reproductive stages for the crops. I think it's kind of, you know, both in corn and beans, right? You know, we had that question, you know, how much did the wildfire smoke impact the soybeans? But a lot of that soybeans, you know, they were in vegetative stages, maybe just started flowering in late June there. But they weren't into, you know, full flower. They weren't into where they're starting to put on a lot of that grain fill. So just, you know, what's so challenging with wildfire smoke is to, you know, actually dial into how much did it reduce
What's
yield.
the degree of severity?
So we have to kind of use different phases, you know, we have to use different studies, whether it be shade or cloud cover, to kind of give us some idea. And looking at those studies, they kind of give us an indication, you know, if it's during the vegetative stages for the crops, you know, they tend to be okay. You get into those reproductive and then also the grain fill periods, that's when we tend to see more of an issue for the smoke.
Very interesting. And one last question on it, not referring to the shade. What about the CO2 that carbon dioxide brings?
Yeah, I was trying to figure out, you know, we didn't really track any numbers in terms of, you know, what the elevation in CO2 is occurring. Now, you take a crop like a C3 crop, right, it's probably going to be a little bit more responsive, a little bit, sensitive to changes in CO2. So if you have, you know, certain levels with higher CO2, it may actually positively impact some of those C3 crops. May actually, that C3 crop respond a little bit more to the increases in CO2. I'd be curious, but, you know, that's part of we need to, as these occur, right, we need to track some of this data a little bit more.
The more you know, the more questions you have, is what I'm hearing about that. That's fair. Well, thanks for taking time.
Yeah,
appreciate it. And yeah, we'll have a link to his work done this past summer. And if you have any other questions, I'm sure you can find a way to get a hold of him. And if not, until then, we'll hope for some smoke in July for our canola, because we know we benefit from that. So thanks.